Alright, well, hopefully this is much better now. I set up my streaming device to be better because I have a very slow internet right now, but that's not an issue. So everything is alright now, and I hope that it doesn't bother y'all that my stream quality isn't going to be very good. I'm on 25 FPS, so it's going to be low quality. So anyway, back to the game. I was thinking for a while with these stuff. Last time where we left off was we appended the call stack to the program counter. We added this virtual memory interface. We had this ALU with the registers set up. We have the stack, and what I want to mainly focus on is this stack because it's not bad necessarily, but it isn't the best either. I mean, first off, it's mirrored, which makes it a bit weird. Second, all of this, it just looks sorry it just looks mildly uncomforting. So yeah, what I'm thinking about, and you can already guess, is I'm going to be deleting this stack and absolutely remaking it. And again, I'm not gonna be always seeing the stream chat, so already I'm just gonna apologize for that. So I'm gonna be occasionally checking the chat, do not worry about that. I will sometimes see your messages. So now you might be wondering how I want to exactly do this stack thing, and I actually do have a solution. Now if you look at my blueprints, which are like saved little modules I have, I'm gonna actually delete this because it just sucks. What I'm gonna focus on is actually this one write, one read register, which means it has one write input, one read input. They're both separate from each other. Now it has inverted control lines, but do not worry, that's not the worst thing ever. So what I'm gonna do is I'm gonna take this register and use it as a stack. And you might be wondering how I'm gonna use a register, a stack, or a register clump. It's easy. We're gonna have a register that is essentially going to be a stack pointer, and that is gonna be our last register. So just to clarify things, this register is going to be our, oh no, how did the S look like? Well, I kind of forgot how to draw an S. Let's just assume that's how you do it. So this is going to be our stack pointer register, which always points at the most recent item. And sorry for coughing. And basically with this, we'll keep track of always which layer we're at, and I will explain why I'm actually using changeable registers, so like write registers and stuff. I'm just gonna complete this and then I'm gonna tell you why. Oops, I went a tad bit further than I wanted to. Alright, here we go. 1, 2, 3, so that's 16, and 1, 2, 3, 4. So this is going to be, it should be equal both sides, yep. So now, the concept behind this way of making a stack is that every time you push something onto the stack in real life, is going to increment a thing called a stack pointer register. This basically, as the name suggests, always points at the top of the stack. So every time you push something onto the stack, it increments. So it always increments and then writes, increments, writes. Now that depends. Sometimes it's in reverse. It first writes, then it increments. Though I don't think that's very useful because then you'll always be reading the empty layer. And every time you pop, you get the what's at the current address, then you remove it and then you decrement the stack pointer. Now why I'm using it like this is because this way I'm not only able to read any layer of the stack, but also write to any layer of the stack with using special instructions. And now that we're talking about instructions, I'm thinking of rewriting a bit of this instruction set. So we got push pop color, that is nice. Now here we got a pointer copy, which is alright, and then what I'm gonna add is a pointer load, which, as the name suggests, is, well, when you write to an element on the stack. So this is a this is how I'm gonna be doing this, the stack part. And 1 second. And so basically, to access the layers of the stack, we are gonna need a decoder, a very big one, because our stack is going to be 64 layers deep, which I think is deeper than necessary. So how we're gonna do this, here are the control lines, right? And I could do this on the other side, but I'm not going to. So we're gonna have some AND gate, ooh, no, never mind, NAND gates, because the control lines are inverted. So let's do this, and then we're going to leave a space here, and again here we're going to do another NAND gate. And I'm thinking of actually, no, that's not good. Let's have the space here, and this isn't very efficient, but honestly I've done worse things, so it's really the best I can do. And so now we're gonna take this and copy paste it pretty much down all the way until we reach the bottom right there. So now you will see that when you press simulation, you can see that they are activated by default, and yeah, that is how, okay, that is how it's supposed to be. Alright. Why does the top row so, okay, my business suffering? Oh, I forgot to set the TPS to 20. Anyway, so here we're going to have the decoders, and for that I should have removed these first. God, I hate coughing. So this is going to be the write, and this is going to be the read decoders part, and I should have thought of this before. And then 1, 2, 3, and so here we're going to have a break, and this is how we're gonna copy down each individual layer. Alright, and now we're gonna place the colored traces, except I'm going to first remove the unnecessary parts. Alright, and so this is 6 tall, I know that, and we need 64 of each. Ooh. There we go. So 1, 0, oops, 2. Alright, they all seem to match up. So far so good. So this is complete, this part is complete. Now for the inputs, did I actually make it 32? Hold on. 192, yeah. Wait, 192, yeah, okay. Yeah, then it's 32, alright. At the bottom we'll have the data buses. Obviously the red and blue halves. One for the input and one for the output. And for that reason I'm going to do something I already do, and that is shave off this layer. I just don't like it, you know. It's kind of in the way, and allows us to make it compactor. So this is gonna be 4, 2, 3, 4, so this long, and then this is unnecessary, and first I will do the traces. Alright. Damn, I'm hearing some weird noises from outside. Anyway, we'll copy paste this and color it blue as usual. Also, I've been looking at this call stack thing. It's looking very uncomfortable, but I really cannot do it any better way, likely. So yeah, it will look ugly, but who said it's like? I mean, look at my third CPU. It's an 8-bit CPU. Look at this. You might think this is beautiful, but then you look here, and you look here. This is not beautiful. This is ugly as hell. So back to my 32-bit CPU. Anyway, so topmost buses, those are the inputs. These are the outputs. Good. God, I hate coughing. Also, I've been pointed a problem with my two write-to-read registers. The problem is that when you write to the same register from both ports, 0 will win, which means if one of the inputs or even both are 0, but if even one input is 0, it will be 0. It's mostly due to the fact that this register is inverted, like the core and the control lines. But apparently that's not the problematic part about it. How did I not delete these parts? So yeah, it's kind of a bit broken, but apparently it cannot really be fixed or so. So yeah, it's kind of stuck like that now. But that's not the main issue, because as of right now we haven't really made any of the instructions except technically no operation, because it's literally the most simple instruction ever. Also, it might be possible that I didn't stream making this part. I don't know. Anyway, I'm going to remove this layer as well, because we don't need it. We already have the control lines. And now that I'm thinking about it, you know, this 16 register thing, it's not bad, but at the same time I'm like, do we really need 16 registers? I mean, look at this. We have 64 layers in stack. You can write and read to any layer. You can pretty much use it as a register file already, even though it's not it doesn't have multiple read ports. And I'm thinking that maybe we can only have like 4 or 8 registers, because this kind of looks like an overkill. I'm not sure. I will leave that decision to you guys instead, because at the same time 16 registers can be useful, but I'm not the greatest fan of it, to be honest. Alright, that's complete. Mostly right now I would say that the closest thing we'll do is probably wiring things together. However, as I'm thinking, as of right now, so this is complete. That's nice. Shift left, shift right. We do not have a shifting compartment yet. That's crazy. I'm gonna go to my old project. No, this doesn't have that. I swear to God, somewhere I had a shifter. Oh, by the way, that's a multiplier. I made this hardware multiplier. It's actually a stunning 17 ticks, which is crazy. And this is another version. It multiplies to 16-bit numbers. Now, this multiplies only to 8-bit numbers, but the output is 16 for both. Anyway, that's not the main point. Why isn't the shift here? Hold on, is it here? Yeah, except it's terrible, and I might as well remake it. Alright. Let's make our own shift instead. Might be a bit better, though I'm gonna go to a test world for that. Alright, so I don't like that. We're obviously gonna have an input for both sides, obviously, but first I'm gonna do a basic version, and we're gonna have to make a universal layer, I feel like. So we're going to read the input and then how do we do this? What is the opposite of an AND gate? Hold on, I need some tests for this. So we put in an AND gate. Here's gonna be an input. Here's an AND gate, and let's see an NAND gate first. That's the first thing that comes to my mind, kind of. So, well, by default, this one is going to be on. When I activate this, it's going to swap. That's not very useful. Let's try an OR gate, which kind of activates by default, and then when you're not shifting, yeah, that's a bit of an issue. Alright, you cannot really do it like that, so we're probably gonna have to get this guy from a NOT gate, and then the other one, so by default, yeah, and then the other one, oh no, this is not good. We cannot have the output there. Now this would be probably the best version, and we definitely need some space. Oops, it's not the trace I wanted. I wanted this one. And then this, maybe. We do need some kind of, oh, so what if it's like this instead? So we could have maybe a bus going for the middle that could be green because it's a control line. And then, so there is this version, read, write, not, and then this part gets its input from the trace 0, so that, you know, this way we have control over it. And the other one gets it. And how do you get that over? Oh no, that's not good. This is complicated because you have two outputs, two possible outputs. One just goes through and the other one shifts. Oh dear, this is hard. Yeah, this is a task now. It is. Alright, what if instead we have it over here, so that's where it is, and then here's the top. So you have this, and then the same thing for a NOT gate. Okay, no, that's not good. And what if instead we're just gonna do a direct connection here, and then a NOT write read into this guy, and boom. I mean, it kind of works now, because by okay, didn't count that in, but yeah, although the slight issue is that when I activate technically it reads both for a split, like only one tick, which is kind of discomforting, but we cannot really do anything against it. Somehow people made these like 4x4 modules, which crazy how you do that. Not sure how they managed to do so. They got some magic flowing in them, or I don't know. Especially because this already is this big, so even crazier. I don't know, maybe like this. Alright, now I'm curious how people did that. Hold on, I'm gonna just check the Discord server. Oh dear, and it logged me out again. Okay, never mind, it didn't, but sometimes it does so. Anyway, there was some kind of shift cell, or I don't know. I'm just gonna check. Shift by one, no. So there was this barrel shifter cell. Oh, that looks absolutely terrifying, and that does. No, that doesn't look very tasty. Is there anything that looks slightly better? One directional. Oh, it's like, but why? Oh, it's a shift register. Oh, that's different. Hold on, shift register isn't the same. ALU without bit, no. I don't want an ALU. I already have one. Well, that looks interesting though. NOR gate. Now NOR gate kinda seems interesting. NOR gate does seem very interesting. I'm not sure how that would work because NOR gate is very sensitive. Just gonna check that, how that's supposed to be. So it kind of turns it off. Yeah, that's very counterintuitive. And then while shifting, so the AND gate shows when it's shifted, but that doesn't make sense. Absolutely doesn't make sense. No. Weird. How do people... I don't understand why. Alright. No, I don't want a shift register, for God's sake. Ow, ow, ow. Ooh, what is this? Oh, never mind, it's brutal in size. 16-bit shifter, no. Here it is. Arithmetic shift. Well, that looks interesting. Are these only using one AND gate? Looks a bit weird. Oh. Oh, well, that's interesting. Alright, that is certainly one way to do it. So basically what they did was kinda move one of these parts out and then use it as like a signal for when to shift, which I guess works. I mean, sure. So that, although, hold on, I think I shifted it. I shifted it myself. So that would mean that you have one trace there, and then the other AND. Wait, where was the other AND gate? Oh no. Whoops. So then the other AND gate would be... Wait, how did they do in the inversion? I'm sorry for pausing and, I don't know, thinking out loud like this. I'm just... I'm just... dear. I'm just a bit confused and stuff. Don't mind me. Wait, it was here a second ago. Hold on. Here it is. So how is inversion? Oh, so at the begin. Oh, yeah, but they did do it like that. They didn't put a buffer gate there. They just kind of did so. All right. Well, that is a tad bit different. And that's a bit uncomfortable. So how do I get the trace to both? Because that's the shared input. Because I cannot put it there. So something like this, but I cannot put the trace directly there, which sucks. Alright, I might have to make this 5 wide. I am sorry. Or 6 wide, even better. But now at least I have space for these. Yeah, but that actually makes sense. So the right signal is... So either one of those can be just active. Okay, that's nice. Although it's a bit annoying that I have this like empty space here and it just wants to be removed. I can see that. I just want to remove it. But I can't because of that. So I put the read there. That is for one, and then the other one would come from a right trace, and that would not be good there. All right, no. You know what? No, let's just make it. Let's just make it that wide. Let's just make it 6 wide. I don't care. This is not going to be the most optimal CPU ever, anyway. So it's not like I'm going for like a world record for like I don't know how many tick clock and etc. etc. All right, that is gonna be that part done. Now that I don't think I want a circular shift. I don't want to like keep the same amount of bits. I want to actually discard the useless parts. So what I'm gonna do is I copy over by 1. Actually, no, we're gonna copy over by 8 times, I think. So this many. Right? Because you can shift by 1, 2, 4, 8, 16, and 32. Okay, no, I miscalculated. This many times. That is 6 layers. And that's the maximum amount of shift we can do. So, and now comes the layer removal part. So on the bottom row, when we shift by 1, wait, which shifter is this going to be? Hold on, I gotta make this second layer as well. I just realized I forgot to properly color. Actually, no, this is going to be this color. This is this one, because it controls both the output or the inputs and outputs and both the controls. Let's say for the other one, which so these are regular data, this is control. Now let's say that this, oh, then I swapped them, hold on, I color coded the wrong layers, and this one is going to be this color, and then this top part is red. Alright, nice. So so when we shift by 1, we're gonna make 2 shifters obviously. So when we shift by 1, let's do left shifting first. So when we shift by 1 to the left, then that means that we either don't or do lose the last part. So by default this is going to be output. So here we're only going to have this part, and then on the next layer we can shift by 2, which means 1 bit is already definitely lost, and the other is going to be this incomplete version, and this goes layer by layer, so the next one can lose 4 bits, right? So 3 are already lost, and then this one maybe. Then here it's gonna be 8 that can be lost, so that is 4 and 1, 2, 3, so 7 in total, and then the half. So then the next layer we can lose 16, which means we lose 15 by default. Wait, what? No, hold on, what am I doing? No. We don't lose them automatically. We just lose half of them. So it's gonna be more like this. Jesus, I'm starting to become schizophrenic. So here we have 2 of these, then here we will have 4 of these half guys. Alright. Dear Jesus, how did I even mess that up? That's my question. How did I? So that is 4 of them. Then we will need 8, 2, 3, 4, 5, 6, 7, and oops, 8. There we go. So now we will have, and then I just realized that this topmost layer is useless because it either makes it disappear or not, I guess. So it kind of has no point. I guess it has no point. The topmost layer, yeah, this one. I mean, oh, I'm starting to slide into the other one. Actually, I'm gonna delete the other one because I don't want to do the work all over. So I'd rather just copy it. So here we're gonna do 16. 2, 3, 4, 5, 6, 7, 8. God damn, that dog is loud. 9, 10, 11, 12, 13, 14, 15, and 16. Right. And now we gotta drag them all. And 32 would mean just deleting the entire thing, so that kinda has no point. Alright. The difference in the other shifter is that instead of making the front, like the more significant bits disappear, you make like the less significant bits disappear. So we'll just kind of move the half parts to the other side. Now I'm just gonna go back to this try at the CPU here we have 4 bits, and yeah, that checks out. So yeah, so you're gonna keep those 8 bits safe. You're not gonna make them disappear, because why would you? Although now I'm gonna see that is 8 half bits. So the next one would be 16, and we do not want that. So back to the test world. Okay, fine, save. Back to the test world. We're gonna delete the uppermost layer because it kind of has no real purpose other than just making it disappear. Alright, so this is 1/2. This is 1/2 of the whole shifter. This is going to be left shift, I think. Yeah. And then we're most definitely gonna have a right shift as well. Now all I'm gonna do here is that write and read should be synchronized between all layers, which doesn't quite fit here, which is a bit unfortunate. Although I think if I do this and then I do this with the read, then I think that by pasting it at the oh, that is beautiful. That works. That works. Was it here? Nope, one higher. Alright, so that syncs the the layers, and now we have to sync all layers together, which isn't gonna be any harder, because actually that's going to be just a binary number input, so we don't actually have to worry about that. So now it's time for copy pasting this. Actually, now I'm thinking, hold on. So we're gonna copy paste this, right? We're gonna just, where did I grab this from? Like here? Yeah, that includes that layer. Alright, good. Now let's say, and I screwed up. So we're gonna copy paste that many away, just right next to. And what we're gonna change is that instead the bits will start disappearing on this side. So that means that we have to recover this side. Crazy. And for that, we'll have to take this, and with empty cells we paste it over. And that is not supposed to be there. Thank you. And we're gonna first paste it over by 1, but we're gonna remove these useless parts. And so now we got the proper way of copy pasting. So now we can just go through the whole thing and do this. And now I'm thinking that technically, no, never mind. Okay, I'm gonna take this, extend it, and alright, that's nice. We got inputs, outputs. So this is gonna input the what am I saying, dear God? This is going to be the left shifter, so I'm gonna put it on this side instead, mostly because this one is complete and this one isn't. So over here we're gonna do pretty much what we did in the previous layer. Delete. Instead here it's a bit easier, but yeah, pretty much just deleting parts. No, hold on, I'm stupid. No, here delete. So here we get 2 of them. Here we need 4, and here we need 8, and that is 1, 2, 3, 4, 5, 6, 7, 8, 2, 3, 4, 5, 6, okay, and then 16, 4, 8. Sorry if the stream gets a bit boring, I cannot really do anything about it. 4, 5, 6, and 8. 9, 10, 11, 12, 13, oops, 14, 15, and 16 finally. And now we can finally connect them as well, which is gonna be a hell of a lot of work, which I maybe should have done layer by layer, so that it kind of speeds up the process. Alright. And we're gonna do the top layer separately, but can't really do anything about that because I already started it, so oh no. God, sometimes this selection tool can be annoying. Although it does sometimes save me from accidentally deleting parts of my projects. There were several cases when I right-clicked accidentally, which is by default the eraser, and I nearly deleted like part of one of those components, which could have resulted in like a not functioning component. But then I realized that I was in selection mode, which kind of saved me. So it does have a good aspect of it, because there is this cool tiling that was added in, I think, version 4.4, 4.1, what am I saying? No, version 0.4 or 0.5, I'm not sure which version it was added in, but they added this tiling and it makes building just so much better. Alright, so we got the two shifters, kind of. Now I'm gonna actually separate them again, which is genius move after I literally moved them together. But the reason is, so I think I said that right is going to be the one that is not, so it has a not gate on it. And then you got the read as well, which is going to be actually our inputs for each layer's shifting. Alright, and that's an issue for sure. Anyway, here we go. Just gonna extend this. So just to test, yeah, and I think it works through the whole layer. And yeah, that looks funny, but it's probably the most compact way of doing this. And we're gonna do the other oh dear, the other side as well. So we're just gonna be copying this and pasting it over here. Ooh, yeah, that seems very good. I'm gonna have to place it like this. It's gonna look ugly as hell, but I can't really do anything about that. Alright, and now the other part that I have to do, and it's going to be painful, is placing down the traces that are actual wires. So you input, the middle is always going to be the input, that's not very different. And I'm going to be placing these in 16s, the group of 16s. And I think they have also an offset of 6, yes. So offset of 6, that's fine. And for this part, I can pretty much just do this. And not this, but this trace. I don't want to place T-latches there, that's not my intention. Okay. So this is going to be, alright, all of them. This is going to be the easy part of placing the traces. And the other easy part is the part where they don't get changed, which is the write input. So that is when they are the same as their input. And then the same here. and on the other side they're going to be shifted by their respective numbers. So on the first layer they can be shifted by 1. Ooh, hold on. Hold on. No, hold on. This is going to be right shift, which means it shifts that direction. So here, yeah, that's trace 1, and then trace 15. Oh, hold on, that's an issue, however, because trace 15 has to go over here. So whatever is trace 0 here cannot reach that part. Ooh. Oh, that raises a problem though. Because I cannot just make a general 16-bit shifter and stack it, because that's not how it works. God. Alright, let's discard the bus idea. Let's make something bit better. Let's discard this idea. What if instead I'm going to give a more general version, although you will need buses. Sucks, because you know, what if you put AND gates and then OR them together, but that kinda doesn't work. So yeah, this is going to be painful. What do I do? Because I do really want to have shifting, because it is an important operation. Do I really need shifting? I mean, I can do left shift by adding this number to itself, but about right shifting, yeah, this is not gonna work. Okay, no, we're not gonna have shifting, even though it would be very useful, and we're not gonna have shifting. Ouch. We're not gonna have shifting. Now that I'm looking at the instructions set, we kind of missed some things, and that is gonna be other definitions, such as now for registers, do we really need this? Is this really necessary? This two-write system, it kind of sounds painful, you know. It's kind of weird. The fact that 0 wins over 1 is also a bit discomforting. So maybe I should replace this with like a regular register file. I'm not sure though, because I have this. I have this version. This is much better. It has 1 write input and 2 technically a write read input, because it has moving between registers, which is nice, and two read ports. Sorry. Although that would be sad, because to be honest, I have this touch screen which I'm not gonna paste because it's okay, somewhere it fits. So this massive touch screen, it requires 2 inputs to register, because that's how you can write both. Because whenever, I'm just gonna show you, so whenever you click one of these icons, it's gonna oh no. Oh no, hold on, why isn't it keeping its state? Did I forget to update the blueprint? Oh no, that's weird. That shouldn't be doing this. Wait, hold on. Oh no. Oh no, hold on, this is the old version. Why do I have the old version saved? Because here, this is the new version, right? This should be the new version. There we go. And if I were to do this, Then yeah. Alright, that's good, that's good. Okay, that was funny. I don't know why I haven't saved the new version. That is the greatest question of the century. I'm deeply sorry. I'm terribly, deeply sorry. So I'm just gonna go to my blueprints real quick and replace this. God. And I'm gonna leave this here. I'm gonna go back. So yeah, I really do wanna use this touch screen, because at the same time it's not just a touch screen, it's also an XY plotter screen. So I can plot an XY value, and I can put either a 1 or a 0 at that coordinate. And I really do want to use it as an output and input device. And that would require me to use the 2 write 2 read register. So yeah, but do I really need 16? Should I really work with, you know what, no, let's keep 16, because I mean it still is very useful, to be honest. It's not like it's useless. You can have a bunch of memory stored at different locations, although register 16 is not register 16, instead it's a stack pointer. So we're gonna have this. Alright, no. So we're gonna have 1 2 3 4 8 16, and these are going to be regular registers, except the last one, there's going to be a stack pointer. And 1 2 3 4 5 6 7 8 9, then 1 for the rest. Oops. 7 0 1 2 3 4 5. Nice. And then for the values, they're just gonna be themselves. So 2 3 4 oops 5 6 7 8 9, A B C D E F, and 1 0. Alright. And can we name it something like, I don't know, how big is gonna, I guess 8 bits is gonna be fine for instructions, so we can name this, I mean that means 24 bit number can be loaded. So I20, ooh, why is it, I don't know, I24, so load 24-bit integer, and then LD load, what should it be? Because I don't know, saying whole just sounds a bit weird, like WHOLE, that just sounds weird. What do we call this? I guess LD, so we got LD24 and LD32, and copy is fine. Pointer load sounds a bit weird because the only pointer you kind of have is just pretty much the stack pointer, so could be rather like STKL, so stack load, and STKC for stack copy. Actually, you know what, I'm gonna give these like this comment next to them so that I know. Ooh, that's gonna be a bit far away. Oh, I didn't mean to. What? You can do this? Oh, I didn't know that. Alright, go back. Yes, this one. Alright, and we're just gonna add an explanation next to each other. Alright, that's good. So, we got obviously got no operation. Then we got exit, which, well, exit. Then load 24-bit immediate to register, and then load 32-bit number to register, which is 2 cycles because the VMem interface is 32 bits itself. So, alright. Then we got copy, which copy a register's value into an other register. Wait, another is one word. What am I doing? Then we got stack load, is load a register's value into a stack layer, into a relative stack layer, and then copy a relative stack layer's value into a register. Actually, I'm going to shorten register into just reg. Because it's easier to type out and also a bit more spacey. I'm gonna finish these later. I'm not gonna bore you with that. I'm gonna do that off camera or something. Now back to the actual circuitry. Am I forgetting something? We have addition, subtraction, that's handled over here, and or XOR and not, and or XOR and not. Push pop is gonna be handled. Call and return is gonna be this one, and then we have compare. Comparison is done here. So it's done with subtraction and it's done also here. Jump is all the types of jumps except for a regular jump, it involves the logic layer, but other than that it's gonna be decided by this latch. And send input output and receive input output, it's gonna be a later thing. It's just gonna send values to a bus, and the difference is that receive input output waits for a signal for the clock to continue. So yeah, these defined. Now no operation. Okay, exit. Okay, the loads, copy. Okay, I think we got every single module, though I'm not sure. Now here's the thing, we can either make a 32-bit multiplier combinational, which would be terrifying because it would be slow. Obviously, it would take like, I don't know, 60 and ticks, which is actually slower than a serial version of a 32-bit multiplier. Or we could make that a built-in function, which sounds a bit more convincing. Opcodes, I'm gonna do that later. Operands, gonna do that later. We got every single instruction needed. I feel like that is absolutely necessary. Alright. Yeah, so it's mostly just wirings and timings, except for the virtual memory interface, because that's gonna be a bit more complicated. So So what is, yeah, read signal means that we want to write to the virtual memory. That's gonna be mstore, and mload, all it does is just go to an address, gets whatever is stored there and puts it in a register, which, although the problem is that a lot of these instructions would likely be multi-cycle, which means they would have to block block the actual clock updates here, which is how do I say, a bit unfortunate and a bit uncomfortable, because, for example, look at memory store and memory load. What does it do? It goes, memory store goes to so it has to push, so that's one cycle, and then goes to an address, so that's two cycles, and it writes, and then for the third cycle comes back. So in total that's 3 whole cycles to do an mstore. Mload is the same, so it's also 3 cycles. And now let's see, compare, jump. These are 1 cycle, that's lucky. This is 1 cycle, this is technically 1 cycle because, well, or 2 cycles, I don't know. This is obviously 1 cycle, this is 2 cycles. Copy is 1 cycle. Stack load is a bit more, actually push and pop is also multi-cycle, because what it does, push writes to here, so that's 1, and then increments the counter, which is 2, so that's again 2 cycles. Astonishing. Great. So how do I do this? And then stack copy, stack load and stack copy is also multi-cycle, because stack load first gets where it should go with an offset, which is 1 cycle, and then reads that value out and activates the register, so that's 2 cycles. And stack copy, no, stack load, yeah, stack load and stack copy is 2 cycles. Alright, so that's gonna be pain for sure. So the problem is that most of these instructions, you cannot do them in 1 cycle technically. You're gonna need at least 2, and that sucks. But sadly there is no other way of doing it. Anyway, enough about yapping. Somehow I should wire these together, but first I'm gonna finish this stack module by adding a decoder for sure, and somehow getting the logic to work in some magical way. And then later we will have to do a decoder for instructions, which I am definitely not gonna do by hand, because I don't even know how many addresses we have for just instructions. So yeah, that will have to wait for a tad bit of time. So first off, this decoder. I think I already have a 4-bit version, and that is already 16. So, and let's see, here's the 1s bit, that's nice. So all we have to do is extend this to be 4 times larger, upwards, and 2 more columns, which I'm gonna be after doing by hand. Hell yeah. So first column, it changes half as many times as the previous layer, and boom, dum, and then we do that again. So okay, hold on, let's go back to the beginning. Okay. Okay. Swaps back. Alright, so this swaps. Wait, hold on, is this right? So where does this swap? When it comes in the middle, that goes out to this side. Comes in the middle, goes out to the side, comes in the middle. So it swaps places again. And then, yeah, okay. So that is one more row, and then we need another, which is luckily going to be also doing half as many swaps. So we're gonna select all this. Boom. And then select this. Boom. Is it so? Yeah. Alright. Nice. That is our 6-bit decoder. Because I think, yeah, 6. Yeah, because that goes from 0 to 0 to 63. Jesus. And now one slight modification we're gonna do is we're going to add these AND gates. Which is gonna be powering those, yeah. Oops. Alright, there we go. And then you can just copy paste this over all the way into the top. Nice. We're gonna add this at the end, and now we're gonna split it into these like whole quarters. Technically, I think they count as quarters. Right. And 1, 2, 3 checks out, and now we're gonna do these 64 of them. Oh dear, it's out of the screen. Does it start with 0 here? Yes. And that is one decoder done, because there is actually 2 of these. Absolutely lovely, I know. Is that even gonna... Oh, that's not gonna fit. No. So we want the blue line and then trace it. Okay, that should be enough. So that is the 2 decoders. One is for writing and one is for reading. Alright. And now we just have to connect them, which is probably going to be the most painful part about the entire thing. So we're going to have the traces here, which are going to be just coordinates, if you want to call them that. Coordinates, what am I saying? God. And 6 times, so we need the last 6 traces. Yep. Alright. Nice. And I mean, technically we can connect them, because they're just gonna be the same address. Alright. And now comes the connecting part. Now we got 4 sections of each. So this, which one should be the right and read? This one's closer to read, so likely that's gonna be the obvious answer. I'm gonna have a read, and then the right goes like all the way up. Which I'm gonna figure out soon how I'm gonna do. This is probably not how I should be wiring these. This is just a test, so I'm just gonna be. Oh no, I don't want that. No. It's not good. Not good. All right, and we need one more. Wait, why am I wiring them all the way here? I mean, technically the second one only has to reach here. The third one only has to reach here. And the fourth one only has to reach here. Alright, we can go a bit more in, and finally connect that as well. Why am I leaving the spaces? That's a great question. Alright. Nice. And this last part. Alright, that is what I just did. Alright, nice. That is the reads. Now the writes have to go all the way up there. Ooh, that's gonna be nice. Somehow we have to make them escape. God damn it. This like heating thing, I don't know what to call it, keeps like screaming because the water inside it just forms air bubbles. It just makes me mildly uncomfortable. I don't know about you guys, but it just sounds terrible. It sounds like it's screaming in pain or agony or something, I don't know. It keeps just audibly doing that. Even during night. Even during nighttime when I'm trying to sleep and all. It just does so. Because why not, you know? So this is gonna be the reading part. I think I can go that close, right? Yeah. And I'm gonna connect these guys by tunnels rather, because it's likely the best thing I can do. Alright, that is one done. Then, oh, that's an issue though. Never mind. I didn't think of that. I'm gonna disable auto crossing for this one. That works with the first one, but the second one is so high up that I kinda need to get the same, like, I don't know what to call this, like the same contraption. Alright, and now we're just gonna again add all of those tunnels. So the second one ends up over here, which is off. Not sure how I managed to do that. Alright, this is gonna need a complete rewiring. So this guy ends up over here. Alright, then the third guy ends up over here, which is likely him, no? Alright, gonna move this up as well. Oh dear, this was not thought through. Oh dear. How did I miscalculate that? That is a great question. I have no clue. So the third one, what did I say about the third? The third one ends up over there. So I bring it out here. Actually, not really. I can just bring it out over here. Oops, no. There we go. And then the last one. Hold on, that level, I think. Let's just check it. Not sure why I'm using tunnels up here, but God knows if I need that space for anything. And alright, I did manage to do the tunnels correctly because it's not giving me any errors, so that's nice. The decoder technically works, so this would be active. It would allow writing to the lowest one, so that's good. Here are the enable lines, which is nice. Now the reason why is there two separate enable lines. The first one is enabled when you're actually doing the process, and the second one is paused when you actually have to do it. So this one just decodes the address and lets you prepare for which address to write to or read from, and then this one just flashes for one tick, and that allows it to work. But since right now none of the inputs are actually true, you can see that none of the reads are being activated. It right now wouldn't do anything really, so yeah. So yeah, and I never thought I would actually make a stack using actual registers, but oh well, look what I have done. Alright, so now that these are also complete, I think what should I move on to doing? That's the question. I don't know, because right now basically I have every module, so what I would have to do is get the opcodes of this, write some explanation next to them, put some operands that actually do something. So right now there is nothing really that I could do physically, I think, because pretty much everything is done. So yeah, I think so. So I think it's all nearly complete. So how long have I been streaming for? Decent amount of time. I think I'm going to be shutting the stream off now. For now, I don't know when I'm gonna be streaming again and what I'm gonna be streaming, but I will figure it out, and obviously I will do so later. So I guess see y'all later. I hope y'all enjoyed the stream, and hope y'all have a nice day or night.